looks like we're live. Okay. Good evening, everyone. Welcome to our live chat. Let me just fix the camera here. I've had a heck of a week. Let me tell you about my week starting out before we go into all the details. I take New Jersey Transit to go into New York City every so often. And I had the wonderful experience of being on the bus with a car accident. I hit my head. Actually, it's right here, or basically right here. Yeah, that's where I got a nice little bonk in the head and almost got a concussion. Did not feel good the past couple of days, so there was a chance that I was not going to be able to do this chat because I was not feeling all that well. But feeling good now. But that's how my week started. Perfect way to start on Monday with being in a car accident on New Jersey Transit when the person in the car was at fault. Because here's a tip, guys, this is basic physics. A larger object is always going to have more momentum than a smaller object, especially if that smaller object is a fiberglass overrated car that is slamming into a bus. Usually not a good thing. So that took out the wheel. I hit my head. It was wonderful. Wonderful way to start on Monday. So that's been fun. And we also had some technical difficulties the other day as well. So it's been a fun week. So the only good news is that the Mets have been playing well, which of course during the live chat now they are down 4-0. So we'll see what happens if they come back. We got that over there as well. And we also had some climate data coming out. Now, we are approaching Earth Day and all that good stuff, and everyone goes on these tangents. The world's going to end. The world is we need to do more, blah, blah, blah. I'm always up for conservation and doing the best we can, planting trees, all that good stuff. But as you know, I am not one for advertising the Sci-Fi Channel, i.e., creating outlandish and insane, high octane, ridiculous nonsense to drive clicks and interest. Okay, if you're interested in the end of the world, hey, look, the day after tomorrow, next week, or 2 days ago is an excellent movie. But if you are interested in real science, it's a little bit more boring. Okay. May not be the end of the world, but it's important to study. So we're going to go over that. And of course, we're going to go over what we're seeing here with our pattern overall and what's happening. So let's get into that data. Because honestly, right now, there really isn't any major storms on the way. There is a very impressive backdoor cold front that is setting up for this weekend, which we'll talk about in just a moment. So let's take a look at our data. And we start off first with La Nina. And by the way, if you guys already know, I am trying to learn Spanish. So I'm trying to work on my R's because I will not settle with butchering just one language, the English language, but I will butcher multiple languages before the end of this decade. So we're going to try and do Spanish, Italian, and I don't know, maybe Greek or something. I don't know. But I will be sure to mispronounce and destroy the grammar of all of those languages and retire even more language teachers like I did to my English teacher in high school. So that is a goal, and I think it's a worthy goal. So let's talk about our La Nina. It is now basin-wide. Now, this is really important. It's really cool because we haven't seen something like this since really the 1970s. It came close in the 1990s, but not exactly like what we're seeing now, where we had initially a weak west-based La Nina about 2 years ago. Then we shifted to a weak to moderate east-based La Nina. And now we have a weak to moderate basin-wide La Nina. 3 different structures of a La Nina state, which I studied as much data as I could over the past couple of days to see if there's anything similar. And right now, I really can't find anything. Now, what's interesting about this La Nina is that it coincides at the same time where we have a perpetual negative PDO pattern. The 1970s featured at times a negative PDO pattern, but wasn't sustained like we're seeing now. But the last time we saw a negative PDO pattern with a major drought at the same time was in the 1800s. And in the 1800s, we had very similar La Nina pattern, which we know based on the increase of tropical activity slamming into Florida and portions of the East Coast. So we are seeing a unique situation where you have a sustained negative PDO, which is this, a 3-peat, which is very unusual. It's almost like a Michael Jordan of La Ninas, setting up in the Pacific that is basin wide. The Indian Ocean is warm. So here's all your convection setting up. And here is your suppression. And that means for the tropical Atlantic hurricane season is that your subtropical jet stream, which gets its fuel from here, is going to be relatively weak, which means low shear. Now, before you jump ahead and suggest that we're going to have a well above normal hurricane season, which is possible, we have to measure and work on what type of impacts this negative AMO feature right here is having on the Atlantic hurricane season. This is a normal process. I know you might see some articles and whatnot touting the end of the Gulf Stream by some individuals out there, some professors, one from Penn State. That I think is inaccurate. I think what we're seeing here is a negative AMO pattern, which features below normal water here, below normal temperatures here, above normal temperatures here. And typically what that means is that you don't get a lot of long track hurricanes that, let's say, start off of the Cape Verdes and then reaches all the way to the East Coast. Instead, you get a lot of development around the Caribbean, around the Bahamas, Gulf of Mexico, rapid development, and then rapid development over the Western Atlantic. Pretty much what we've been seeing for the past 3 years. The last time we saw something like this was in the 1950s. So it's a very similar pattern, very similar setup developing. But unlike the 1950s, this is coinciding with a 3-peat La Nina with a negative PDO pattern in the Pacific, which all sets up the support for a Western Atlantic ridge, which we'll get to in a moment. So that's where we are in the forcing for the ocean temperatures and the gradients that we're seeing here. This all points to a very active season for thunderstorms in the plains, in the Mississippi River Valley, in the Tennessee River Valley, which we've been talking about for some time and that we have been seeing increasingly so. We haven't seen anything yet. Wait till we get to May and June. It's just going to be off the hook. But it also sets up a very interesting dynamic when we take a look at what's happening, if I pull up the right map, with, here we are, with what's going on in the stratosphere. Now we're seeing a lot of cooling going on here. We were expecting this cooling because we're seeing more increase of the sun and our ozone's getting broken up. That process leads to a lot of cooling, which leads to what we're seeing now. Well above normal to start, and then we see a rapid cooling take place as the ozone's destroyed. Now this process, while it cools the stratosphere overall throughout much of the northern hemisphere, it also opens up these warm pockets and cold pockets, which sets up upper level lows, which we've been seeing quite a bit this spring. So for some of you guys, this is review. And some of you might be new information, but what it tells us is that there is potential here for severe weather outbreaks to become sustained with prolonged high latitude and mid latitude blocking from these upper level lows and creating a dynamic clash of air masses. And I started to mention this over the past couple of days in the premium section. So let me pull up the 500 millibar pattern here. Now, this does not mean that we're going to see this setup all spring and all summer. But I want to explain to you why this has my attention. Because in a La Nina pattern, you typically get your ridges to develop here and here. And you kind of get this weakness somewhere around the central to eastern Gulf Coast. So typically, without our high latitude blocking, without our upper level lows, what you end up with is a pretty impressive Western Atlantic ridge with the transport of warm, moist air driving up the coast, usually coming in from the Mississippi River Valley and Tennessee River Valley and pushing into the northern mid-Atlantic. We get a lot of our heat waves this way. But what's interesting this year is that we have more support for these pesky upper level lows to set up anywhere between the eastern Great Lakes and the northwestern Atlantic. And that sets up backdoor cold fronts. If you don't know what a backdoor cold front is, you're going to get a harsh lesson in it this weekend when you compare temperatures between Connecticut with temperatures in the 50s and Philadelphia with temperatures near 80. So basically what happens is that you get these upper level lows setting up here. And what happens is that the circulation of the upper level low allows for air masses that are in the Canadian Maritimes to bleed down through New England and basically start to stall out somewhere between central New Jersey and the New York City metro. And that leads to usually about a 10 to 20 degree gradient over our area, sometimes as much as a 30 degree gradient, and just a lot of unsettled conditions with a lot of mixed clouds. Okay, not a lot of rainfall in these type of scenarios because of this feature right here. When you get this type of signal where you have your height lines converging here, which means that your winds are converging here, it leads to convergence and confluence. So you're packing more air mass into a smaller space, and that forces sinking air. So it suppresses precipitation potential, but it keeps that dynamic in place for the air mass clash to support broken cloud cover, mix of sun and clouds, and generally raw conditions along the coast. So that's how we end up with what we're going to be looking at for this Sunday. If you're on the east of Long Island, you'll be struggling around the upper 40s. If you're in Philadelphia, you'll be pushing close to 80. Now that is what I call a heck of a thermal gradient. And this is completely normal, by the way. This isn't some unusual, crazy scenario or, climate change or anything of that nature. This is our pattern, especially in the spring. You get these dense polar maritime air masses around the Gulf of Maine. They're able to push south. They run into warmer tropical air that's trying to push north because it's that time of season. And you start to see that change. And you start to get these clashes setting up. Usually they become less impressive as we move into the summer months because the air masses overall start to moderate. But this year might be a special example of that not being so much the case. So, how long does this pattern last? Well, let me jump all the way to June here. Now, this is the European guidance 46-day forecast. And again, you never take any of this stuff verbatim. But I found this very interesting. I've seen this in several runs now, where we're gaining more and more support for a ridge here and a ridge here. And your weakness right here. You're also gaining support for a trough of some kind here and above normal heights showing up out here in the Western Atlantic. Also, frequently, we've seen support for a trough around the Aleutians. Why do I find this model data interesting? Because it matches up with what you would expect based on the observations we just went over, almost verbatim. This feature here is set up by your negative PDO pattern. The weak subtropical jet stream is supported by La Nina. The ridge orientations are set up by a basin-wide La Nina. The support for a trough or some sort of weakness around the Canadian Maritimes up to around Greenland is supported by your slightly warmer anomalies showing up in the stratosphere in these locations constantly, and also supports the potential for your sustained upper level low development. And then finally, your Western Atlantic Ridge sets up perfectly because you have to have a counterbalance with the trough and below normal heights here with above normal heights here. So you end up with tropical air trying to push northward and maritime air masses trying to push southward, and we are caught in between with the potential for tropical moisture interacting with all this mess. So it's very interesting to see this type of pattern showing up in the model guidance, not because, hey, look, it's the European, it's a great model, but because it makes sense based on the observations we are seeing now and what that means in the future. So a good rule for you young meteorologists out there is that when you're looking at a model and you're looking at something long range, what you want to do is not worry about what the model is saying per se, but ask yourself, do the current observations support the potential evolution of what you're seeing 5, 10, 15, 45 days out? And if they do, then you could put a little bit more weight on that evolution, not worry about the exact details, but the overall theme of the pattern. So I hope you see like how that process works. Next, let's talk about the climate. Some interesting data came out there. Now, I'm not going to read this entire thing because this isn't dynamics class and I don't want to put you to sleep, at least not yet, okay? Regional sensitivity patterns of the Arctic Ocean acidification revealed with machine learning. This is a really, really good study that I think you guys should definitely read. What's interesting about it is that it's measuring the current state of CO2 in the oceans because of the warming of the climate, okay? And we know that we're seeing warming, especially in the Arctic, based on the loss of sea ice and the evolution of sea ice recently, and the way that it's evolving, okay? And the unique chemical signatures that we're seeing in the ocean. So what it does is it extrapolates based on our current trends on the way that we're putting in CO2. Now, a little caveat here is that they went with a range from the lower section, SSP 2 to 4.5, to the higher, SSP 5 to 8.5. Understand what this means. SSP 2 to 4.5 is a scenario where everyone goes to nuclear and green, and we stop putting out CO2 completely, and we all eat Brussels sprouts, which is highly unlikely. And then 8.5 is we all say screw it, and we're all going to burn coal in our backyard, okay? Which also is unlikely to happen. So more likely you're in somewhere between the 4.5 and 5 range, which is kind of like your midpoint, or basically where we are now. So you want to stay, when you're reading these studies and looking at the data, you want to stay away from the extremes. All right, SSP2 is basically fairy tale land where everyone gets green energy and everything works out perfectly and a unicorn shows up and it's wonderful. 8.5 is we all go and burn coal and we chop down all the trees and we I don't know, just throw garbage in the ocean constantly, which isn't too far away from what's going on in Asia, and we just completely forget any type of improvement of technology. Those two extremes are the two least likely, and you should probably stay away from when you're reading these studies. Now, I wanted to go over that aspect of this study because I want you to be able to read these studies intelligently. I don't want you to just follow whatever I'm saying and then just repeat it. Go read the studies yourself. I saved them on my Twitter feed. Read them and then understand that the two outliers, the two extremes, are the two scenarios that are the least likely. But you're going to see the worst case scenario being repeated constantly on social media and the news more often because that's what's going to get your attention. Another study, another discussions by Gavin. Now, let me just scroll down here. Gavin is one of my least favorite, actually not even my favorite, climate scientists. We differ quite a bit on the way to handle discussing climate change. But I think it's important to read this discussion on what he thinks about in terms of how to put out data and how to quote unquote tell the truth. My approach is that I'm going to give you the data, you read it, you make your own decision. Because I believe you're intelligent. Because after all, you're following me, you have to be. But he does not. He assumes that you just don't understand anything and that it's important to basically focus on the worst possible scenario. So definitely read that so that way you understand. And basically what I'm saying, he would consider disinformation, which I find interesting. But I would say that you should definitely read that. And then another discussion by Roger Pyle Jr., he does a great job of explaining, okay, here's where we are, and focuses on the technology aspect, which is something I do quite a bit. He does a really great job of breaking down a lot of the data and a lot of the current evolution of energy that is taking place. One thing that's really interesting is brand new is that some states and public utilities are making the case for setting small nuclear reactors in former coal plants. So you eliminate the coal plants, but you don't have to rebuild a new nuclear power plant because you have these smaller nuclear power plants that are able to be developed within them. And so you reduce the carbon footprint of new construction and at the same time increase your energy production. And also at the same time, these new reactors are able to reuse old rods so that way you can reduce nuclear waste. So very interesting stuff, that is for sure. And one of the interesting things is that our current policies on energy worldwide are trending more and more below the 3 Celsius range. And a lot of the goals with our energy potential is focusing more below 2 degrees Celsius. So what this is basically telling us, what this chart is basically telling us, is that our technology potential and our research is allowing us to push that influence, that potential of rising above 1.5, above 2 degrees Celsius, towards a more likely scenario of staying away from that worst case scenario. And we are nowhere near 4 degrees Celsius, which is what we constantly see on TV and news and whatnot. But in reality, we're moving far away from that. So that's certainly some good news. But again, read these discussions yourself, learn about them, understand what they're trying to say, and then go back to the IPCC report and read what they're saying, the pure data, not just what they put out in the media. So that way you have a better idea of what is going on. Always go with the real science, with the pure science. It's a little bit long to read, but it's well worth it. So that way you make a better decision on how to handle climate change. Basically, I understand not everyone can buy a Tesla, but you can do a lot by investing. So that's where I am tonight. I'm going to take your questions. We have quite a few questions here on the community chat and a couple of them also on YouTube. So we're going to check that out. But first, we're going to start off with our live chat and premium area, and then we'll answer the best question out there for YouTube. Let's see what we got here. Okay. There's a difference, okay, card access. There is a difference between disputing the extent of the impact that people have or particular emissions have on climate and asserting that climate isn't changing. A lot of climate alarmists deliberately distort nuances raised by people challenging them. It's interesting that you bring that up because I came across a Twitter feed today saying that there has been no climate change, that we haven't seen any warming temperatures since 1990. Because they focused on the pause that did happen between 1997 and 2004, which was primarily driven by a very strong negative PDO pattern period in the Pacific, coincide with a west-based strong La Nina. So it caused kind of like a flat line in the warming of the atmosphere. Those type of feeds that put out like, hey, has been no climate change. And I read it. I read the whole time. I'm like, this has got to be a misrepresentation. Maybe I'm reading this wrong, right? So I read the whole thing, went down the whole rabbit hole. And what they're doing is taking data and piecemealing data and not taking the full study. So, and then trying to make their case. So, for example, if a scientist says, well, the Earth wasn't warming from this period to that period, and the study is back from 2002, but you're treating it like as if it came out in 2022, that is misleading. And you're seeing that a lot. Now, I'll give you another example. On the other side, we have a study that found that if you melt all the ice on Earth, that all the cities would be underwater. You usually see this constantly being recycled in the news in May and in October. And typically what they do is they take the worst case scenario and assume that all the ice throughout the world is going to melt. That is highly unlikely because, first of all, if you melt all the ice in the northern Atlantic, you actually shut down the Gulf Stream, which would then cause massive cooling, and basically it would cause some serious problems for agriculture and cool the northern hemisphere quite a bit, which would then reinstate the ice. The Earth just doesn't boil over. It has mechanisms to balance itself out. Very messy, nasty mechanisms. So I wouldn't want to push that lever, so to speak. But again, that's another example of taking data, not explaining the full breadth of the data, and creating the worst case scenario, or in other cases, no scenario. I consider the people that say that there's no climate change and the people who say that the world is going to end are the same group. They're the same group on the same coin, just different sides. But it's the same nonsense. It is trying to create hysteria and basically a lot of confusion out there. How about those sunspots? Indeed. Let's take a look at that. The sun is incredibly active right now. Those who were concerned about a grand solar minimum, that threat is going bye-bye. Because solar cycle 25 is just blowing away in terms of activity and what was even expected, what was even forecasted. So very impressive scenario setting up with solar cycle 25. We are seeing more and more active. Now we're seeing M class, X2 class. These are very strong sunspots, and they're starting to impact the Earth in a great deal. It's probably one of the strongest periods of solar activity I've seen in a decade. So some very impressive sunspots, a lot of flares. I expect this to only get stronger as we move forward. So what that means for you is that if you have direct TV, satellite TV, you like to use your cell phone a lot with 5G and all that stuff, expect disruptions because the solar activity is going to play havoc with a lot of the satellites out there. So just be prepared for that. I thought you knew Italian already. I know all the curses, and they all from my grandparents, so you can thank that. But I want to learn like proper Italian, so I plan on trying to do that very poorly. Indian Ocean looks like it has warmed quite a bit. Yes, it has. Is that the most seasonal, or is that due to impacts from La Nina? A little bit of A, a little bit of B, kind of both. The evolution of La Nina is definitely contributing to that evolution that we're seeing in the Indian Ocean. The cool pool from the negative AMO seems to be spreading. Am I looking at that right? Yeah, it has. It has intensified over the past couple of weeks. We'll see whether this is sustained or not. We saw this last year, but I think what we're going to see is that this start to shift back towards near normal, this area, and this area remains slightly below normal. Right now, it's pretty robust. I'm not sure how long that's going to last, though. I think this is going to start to moderate a bit, especially as we head towards June and we get more of that direct sunlight on the ocean here. We should see this trend more towards near normal, but it's still enough to have an inhibiting factor on the Cape Verde season. Severe weather outbreak 2008 June Ring of Fire. Yeah, it is possible. Definitely. I could definitely see a lot of, I guess you could call it MCSs dropping south from the Great Lakes. Something to really keep an eye on. Took a look at Earth New School. Okay, let's take a look. And we'll go to 10 millibars. Let me zoom out here. All right, so what are we observing here? The polar vortex is dead. Yep, that's completely normal. There's a high in place. 70 millibars is over Asia, which is right here. That's what you're looking at right here. This is what's left of the polar vortex at 70 millibars, and this is basically starting to collapse as well. It's no longer in a strong, tight circulation. It's now becoming more broad, starting to collapse, and that process will continue as we move forward over the next couple of weeks, which is, again, completely normal. So basically, expect a lot of surprises as to warm, hot, and cool days with long-range temperatures forecast being useless. Is that the right take? I would say that if you are focusing on the temperatures, like those 15-day temperatures, yeah, highly volatile. But if you use the long-range forecast as an overall theme and prepare for those themes, it should be pretty accurate. So what I mean by that is that if you're looking to see whether or not 15 days from now, if it's going to be 75 or 55, flip a coin because it's going to be going back and forth at least until you get down to day 7. However, if you are looking at this in terms of, okay, is this type of pattern with a backdoor cold front and unsettled condition going to remain sustained? That is of high confidence. So I think you can see what I mean by that. I remember one time when I spent a summer in DC in the mid-1980s, flying up in mid to late June. It was lower 90s in DC, upper 60s in Newark. Yep. That's exactly what we're talking about here. Let's see. Gavin, along with Man, I also know Man very well, believes anyone who disagrees with him should be silenced, and he actively tries to silence people who disagree with him. He certainly blocks quite a few. I mean, look, if you want to block like the average person, that's on you, whatever. I've yet to ever block another meteorologist, even when we disagree. And there's sometimes we disagree. But that's the point of science, is that you disagree with people and you try to figure things out and you debate, you try to put your ideas and your theories up against someone else. There are quite a few people on Twitter that I know of. I won't say their names, but they're doctors and their fellow atmospheric scientists that we disagree on things. But I follow them and listen to everything they have to say, because if you do not expose yourself to people who disagree with you, then you cannot possibly sharpen and improve your theories and the way that you look at the world, because sometimes they might be right. And so therefore, by reading what they have to say and taking that in and learning from it, you become a better scientist, because either you're going to have found a better way to prove what your theories are, or you're going to have to change your theories and change your understanding of the atmosphere and the world around you. And the only way to do that is to expose yourself to people with different thoughts, ideas, and the way that they see the world. You can't do it anywhere else. And you sure as heck can't do it by being encased in a bubble where everyone agrees with you, which is basically surrounding yourself with yes people. It's not a very good recipe for success. Let's see here. Has anyone studied the impact of removal of particles or pollutants that were common in the mid-20th century and the impact on climate? Yeah, there's actually a really good study coming out of Rutgers that they're working on that right now. And the reason why they're working on it is because there is a lot of push for carbon capture and pulling the carbon out of the atmosphere. So the question now is, okay, if you do that, how much carbon do you pull out, and what impacts would you have on the atmosphere as a result? And would it matter if you do it rapidly or if you do it slowly? And how does that all interact with the atmosphere and the chemistry of the atmosphere, from everything from ozone development to the impact on volcanoes and so on and so forth? So they're working on those studies now, and they're being supported by the same industry that is trying to develop carbon capture, so that way they utilize the technology in a safe manner. So they're working on those studies now. The preliminary studies are interesting, is that some of the pollutants that we used in the 70s, like aerosols, did help to cool the atmosphere, which is pretty interesting. And that may be a factor again, but one of the really major concerns, everyone always talks about CO2, is methane being a problem. So definitely check that out. Methane is far more concerning, by the way. We'll definitely be interested to see if solar activity being more active is a sign that the sun is going to be more active for a while, or if it's a sign that the cycle will peaking early and then going quiet. We'll see. We're going to be learning a lot. Okay, let's check out YouTube. But holy smokes, look at this. All right, so let's take.
Person has the same question 3 times.
Well, sometimes it's repetitive. Let's see here. What is the difference with a backdoor front and a cold front? Okay, a cold front. It's a good question. Fair question. Okay, so here we go. Okay, so this is our map. Let me pull off the radar and surface fronts. Okay. Typically, a cold front comes in from the west, out here, right? So it comes through the Great Lakes, Ohio River Valley, marches across. We get thunderstorms. Yay. A backdoor cold front typically starts off as a boundary over northern New York and New England, somewhere around here, and then slowly drops south and southeast through New England into the New York City metro, and then basically stalling out somewhere around the Delaware River Valley. If you get a high pressure system that is strong enough around Maine, every so often you can get as far south as getting down towards Virginia through central Pennsylvania. So that's a backdoor cold front. Usually a backdoor cold front retreats as a warm front as the maritime air mass loses support. Let's see here. Everything I discussed about the hurricane season, basically we already went over that. But I will say that I do like the idea of an active season, but I'm still working on the details, which I'll have out in May. What is it about this pattern that encourages cutoff lows like the cannonball on the European today? Okay, that's a great question. And let me pull up some data here. Let's say, yeah, we'll do this right here. Temperature anomalies. We'll do 12Z. And this is the current state right here. And this is at 50 millibars. Now, currently, we have all this warm air at 50 millibars. And then you start getting these cold pockets showing up here, right? Well, what's happening in the atmosphere is that the stratosphere, as it's warming on average, is going to develop these warm pockets and cold pockets. Now, cold pockets in the stratosphere causes contraction, which means our 500 millibar heights rise. Warm pockets in the stratosphere leads to expansion, which means you have the troposphere gets pressed down, which leads to below normal heights. Now, when you combine this environment with a La Nina environment, where the subtropical jet stream is weak and the polar jet stream is strong, you're able to get these strong vorticities at the base of these troughs to dip into the mid-latitudes and get cut off from the main jet stream. So this process leads to a upper level low to form that eventually reconnects with the polar jet stream and opens up, but it leads to these bowling ball cut off upper level lows. So let's take a look at this solution here. In fact, I got a better idea. Let's look at the winds here. Okay, so here's your polar jet stream here. Here's your subtropical jet stream down here. And here is your strong vorts, which we could see here with the stronger enhanced upper level winds of jet streaks. Now watch this evolution here. Your polar jet stream starts to get cut off here, and your upper level low starts to form down here. Notice the winds are starting to cut off and form a closed low. Now that evolution eventually leads to the polar jet stream breaking off as it normally does because it's still lifting northward, but you get that piece that's able to cut off away from the polar jet stream and form our upper level low. And then it's able to spin here and circulate until it starts to reconnect with the polar jet stream later on. So that's how you get this whole evolution to take place, is that it's able to cut off from the main polar jet stream and spin about. Let's see here. Any other questions? Okay, I think I answered the other questions. I think the other questions are pretty much a repeat. So let's take a look at what's back here in the community chat. Just an update on the Mets game. They might actually lose this one. They're down 5-0. They can't win every one. You know, I'm sure you could try, but, you know, sometimes you don't win all. Let's see here. I'm thinking of things like that. All the soot in the late 1890s to early 1900s that caused things like poisonous smog in Pennsylvania and all the low-level pollution. Yes, that definitely is a factor, but it wasn't it is a limited time frame on how much impact it can have. I'll tell you what will have a significant impact, and it's kind of interesting in terms of what's going on in Freehold right now, where they're talking about building a lot of homes and a commercial center in what's currently a farm area. That farm area right now radiates very easily. So it cools the atmosphere, right? Because you're having radiation cooling and whatnot. Now pave that over with cement and build a bunch of buildings with heating and lighting and whatnot. You lose your radiation cooling, and now you have more heat. What's the bet that Freehold overall will see warmer, low temperatures moving forward, i.e., urban heat island effect? that will have a lot more impact on the overall microclimate and mesoclimate of a region than the pollution from the 1800s. So just kind of give you that kind of example. Let's see here. Is it going to be cold again after this? Well, I guess it kind of depends on what you consider cold, but definitely cool. I definitely put it this way. Um, we're going to see a lot of days we're going to have an easterly wind and it's going to feel kind of raw out. And it's kind of a hoodie weather, okay? If that's a good example. Um, I like the idea of just a,
On that too, there's like
are we going to see strong storms? Well, again, it's kind of a vague question. Sure. Yeah. I mean, every year we see strong storms. Absolutely. Uh, as more runoff from development as well. Yep, that is true. The way that we develop our infrastructure is going to be extremely important going forward if it hasn't been already. And it leads to a scenario where if we aren't careful, we're going to have a lot of urban flooding problems. And I'm really concerned about that in central Jersey with the way that our river systems are around here and the lake systems and ponds. If we aren't careful, we're going to be ending up with a lot of scenarios of pretty significant urban flooding. So it's something that I think that really needs to be looked at if we're going to be continuing to build around Monmouth and Freehold Township. Okay. I think we're doing pretty good in terms of discussions. A lot of great questions tonight, guys. Absolutely outstanding questions. Let's see if there's anything new with our storm. I'll bring back our radar and surface map. Now, this is pretty interesting, this whole setup here. By the time this frontal boundary gets to us, it'll just be a few scattered showers because it's going to be running into convergence and confluence. Let me pull up 500 millibars here. And so our 500 millibar pattern here is set up so that by the time the trough gets to our neck of the woods, it's going to be minoring out. And we're just looking at a few showers on tomorrow night. Nothing really too significant. So if you're going to the Mets game tomorrow, really it's going to be absolutely beautiful weather for the game. Not expecting any type of weather impacts. Ironically, I had Yankee fans contact me asking me for more rain. So I don't know. Apparently, I guess some of you guys aren't happy with the pitchers or something. I don't know what's going on. I just pay attention to my own team. Okay, so I think that is it. Open it up for more questions if you have more questions. Other than that, we will shut it down for the night. So get your questions in over the next couple of minutes, and then we will call it a night. Let's see. I think we're good. Babe, how is it on YouTube? Any more questions? Okay. Yeah, that's true. Okay. Oh, let's see. As Bristol, Tennessee Sunday night, there was a great example of impact of low-level dry air on precip. Radar shows good rain on track, but for a while there was no rain or just very light sprinkles at the surface. Yet, especially around the Tennessee River Valley and the Appalachians, you can get these dry pockets set in that higher up in elevation, it's pouring, but as you get down towards the valley, it's almost nothing is falling. That can lead to some pretty significant runoff and some flash flooding events. We don't typically see that type of an extreme event around here, but you can see it on the leeward side of the Appalachian Mountains, especially around eastern Pennsylvania and western New Jersey, where you kind of get that dry air kind of briefly trapped in the Delaware River Valley. In our case, that we're going to be seeing over the next couple of days, it's going to be the significant low-level moisture coming in from the Atlantic It's going to create a lot of scenarios of low clouds and drizzle and a few scattered showers here and there. Not looking for a lot of rainfall, though, over the next 10 days. But we'll keep an eye on it and see how that evolves. Okay, well, it looks like that's about it for tonight. I am pretty much done. I'm going to get some rest and see if the Mets can come back. So, again, thank you as always for coming into our chat and checking everything out and asking those awesome questions. I will see you next week. And as always, stay safe out there.